The position vector p at time t seconds is given by r of t is 2 cos t I plus 3 sin t j, and this is in centimetres, and I like column vectors, so I'm immediately going to go to 2 cos t, 3 sin t, which is an ellipse going around the origin. So what do we want to do? We want to find the times when the velocity is perpendicular to the acceleration for t between 0 and 2 pi. So v is going to be negative 2 sin t, 3 cos t. And a is going to be negative 2 cos t, negative 3 sin t. So v dot a is going to be 4 sin t cos t take away 9 sin t cos t. And that is just, remember how to do the dot product of that times that, added to that times that. And that gives me negative 5 sin t cos t, which is negative 5 on 2 sin 2t. So for that to be 0, we need 2t to be equal to some multiple of pi. Remember, the sign is 0 here and here for n belonging to z, which means that t is equal to n pi by 2. N belongs to z, as we outlined in the last lesson. Find the minimum and maximum speed of p and state where and when these speeds occur for t between 0 and 2 pi. Just before I go ahead and do that, I've just noticed that this one did say for t between 0 and 2 pi, and I've sort of given a general. So this would be in that range, pi by 2 and 3 pi by 2. Now let's do the minimum and maximum speed. So going from the velocity here, the magnitude of the velocity, the speed, is the square root of, so we've got to square the negative 2 sin t, so that will be 4 sin squared t, and square the 3 cos t, so that's plus 9 cos squared t. And what I can do here is I can rewrite that a bit as 4 sin squared t plus 4 cos squared t plus 5 cos squared t. And then this, since we know sin squared plus cos squared is 1, is 4. So we get the square root of 4 plus 5 cos squared t. So v min will occur when cos squared t is 0. That's the smallest what's under the square root can be. So that would mean cos squared t equals 0, which means cos t is equal to 0. And so that would be t is equal to pi by 2 and 3 pi by 2. V max means that cos squared t would be 1, and then what's under the square root is the largest it can be, which is 9. And that happens when cos t is equal to 1 or negative 1. And in that range, that is going to happen when t is equal to 0, pi, or 2 pi. Sketch the path traced by p, indicating its direction of motion. Locate on your graph the location where p is losing speed and picking up speed for 0 to 2 pi. So remember that r is equal to 2 cos t, 3 sine t. So at t equals 0, it would be at 2, 0. So it's going to start here. T equals pi by 2, it would be at 0, 3. And we can then see that it's going to go here and here. And so we have an ellipse like so. Okay, so we know that the start point was here. And that was t equals 0. Then t equals pi by 2 was up here. And so we know the direction of motion is going to be like this. The maximum speed was here and here, and the minimum speed was here and here. So it's slowing along there, speeding up along there, slowing here, and speeding up here. Note, and you can refer back to earlier, the maximum and minimum speeds occur when v of t and a of t are perpendicular. In other words, where v and a are equal to 0. In fact, we could just go and have a look. So we found those times, and then for v min we found exactly the same times.